Welcome to Team xAPI and LiveCode, creating an LRP with LiveCode. Note that an LRP is a learning record provider that can send an xAPI statement to a learning record store. First, we should mention the 7 team members who worked on the project in many ways. Just a few of those are learning LiveCode, contributing their code, testing applications, sharing presentation knowledge, and active participation in Zoom meetings. On this slide, you can see their names. They will also be helping with the presentation today, answering questions in chat and demoing as we go. Next, a bit about LiveCode. It's both an open source and commercial development environment. It's a GUI-based development environment with an English-like scripting language that integrates the language with the user interface. Development involves toggling between run and edit modes. There's no compile time. It uses cross-platform code for applications that can be published in iOS, Android, for Macintosh, Windows, Linux, and even web or HTML formats. We've produced these projects so that you don't need to start from a blank page. Your process would be to download LiveCode, pull our xAPI examples from GitHub, revise the code with your LRS credentials. If you don't have an LRS account already, xapi.com's adopter page gives you a list of LRSs. Most of them have a free account option for you to get started testing. Next, you would need to test the LRP application in LiveCode. You can see your statements in the LRS and then modify with your content. Modify the LiveCode project with your content. We're going to walk through each of these steps as we go on. We have a series of demos that are focused on the creation of the learning record provider and document the progress we were able to make in an agile development effort where we had individuals and small groups working in parallel on the different features sets of the project. The different contributions of some of the team members are listed here. So Joan's demo shows us the initial LRP created by Joan along with the final user interface on this slide. This is the first LiveCode project that successfully sends an xAPI statement just using xtalk, the LiveCode scripting language. Joan's demo will walk us through the project interface, how it works, and some of the code. Now we'll hand things over to Joan.
LiveCode team because I wanted to create a mobile version of the xAPI reporter. It's a tool that runs like an extension in your web browser. When you visit a web page, you can rate that page and the reporter will save your rating to an LRS. This screenshot shows that I gave my cohort experience a rating of 5 out of 5, and that rating is now stored in my LRS. So my plan was to learn LiveCode and recreate the xAPI reporter as a mobile app. Well, that was the plan, but that's not what happened. Instead, I made this app. It's not the reporter, but it has basic functionality for creating the real reporter or any other learning record provider. Here's how it works. If you enter an LRS endpoint, the LRS API credentials, the user and password, and an xAPI statement, the app can send the statement to the LRS if the app is online, save statements locally to a file for instances when the app is offline, send statements stored in the local file to an LRS when the app is back online. Now that I've described what the app does, I'll show a little bit of the code. This is the app populated with an xAPI statement and information about the LRS. This is the code that sends the xAPI statement to the LRS. I'll explain how it works. When the user clicks the Post to LRS button and releases the mouse, the on-mouse-up handler is called. There are 3 parts to the code. First, we got the LRS information and the xAPI statement from the text fields and store them in local variables. Next, we use those variables to set the HTTP headers and post the xAPI statement to the LRS. We encrypt the API user and password. We set the content type to JSON, and we set the xAPI version number. After setting the headers, we tell LiveCode to post the statement to a URL, which is our LRS endpoint. Finally, we put the results from the post command in the results field of the app. This lets us know whether the xAPI statement was posted successfully or if there was an error. Quick demo of the app. I've set the endpoint to a grass blade LRS. Now I'll open the web page so we can see the xAPI statements after they are posted in the LRS. So first, let's post or send this statement directly to the LRS. According to our results section, the statement was sent successfully, and when we look at the LRS, I'll refresh the page. We'll see that Dwight Schrute experienced the LiveCode demo. Now, to demonstrate saving to and posting from a local file, I'll save the current statement and then edit it to change the actor to Stanley Hudson. Stanley works in sales, so we'll update the email address to sales@Dunder-Mifflin, and then we'll save this statement to the file. And now we should have two statements to post to the LRS. So I'll post from file. There's one statement posted, the second statement posted, and if I refresh the LRS page, we'll see Stanley and Dwight Schrute both experienced the LiveCode demo. And that's it.
Thank you, Joan. Joan's xAPI reporter stack or LiveCode project was elaborated by creating a card for each of the verbs listed here. It's saved and published as xAPI reporter. The cards were elaborated with navigation, selected, and grouping of the objects within LiveCode allowed us to mark them as a background object, which is a concept that lets grouped objects like fields, buttons, and other user interface objects appear on multiple cards while allowing unique data to be stored in each instance of the object of the card. Now, Kevin's going to do a demo of the version 209 app and show us how we can send a statement from this version of the app.
All right, there it is.
There we go. So yeah, click on some of those buttons, see if you can move around. You're on initialized.
All right.
You just send a statement. That's awesome.
Wait. Interactive.
So on the settings tab, you can set your LRS endpoint, your username, your password. There's also a dummy statement you can tap. Let's talk about this project. So this project elaborates on the verbs in the video profile from the ADL. And the idea is, as we're working through this, we can look at the code.
Is it coming through?
Yeah. Oh, we have to need to check the.
Yes. And then the rest of the verbs, here we're on interacted, is got sample code in the field, and then you can post that and get a result. But you can also go in and edit that, and we'll show that in a moment.
Do you want me to hit anything else there? Have we got them all? Pause.
As we jump into Seeked, we're going to see another sample xAPI statement. We can click the post button, send that, and in the results field, we get status of success, and the response is actually the ID that the LRS assigns to that statement it's just received.
you want me to turn the screen back to you?
Yeah, I'll take a look at Storm Cloud and see what we see here.
Okay.
Before we started, that had the LRS data up here. So before you started, 2021 4/19 was the last date I had submitted. I just opened this tab, and this is your data.
All right.
So 4/21 is what you just sent from that standalone.
Cool.
You could edit the email and the name of the person, so
All
it's
right.
you.
And then put my name here and see what happens.
Yep.
And then post it.
Yep.
Okay, it works, so it should
looks like
pop
it
up
worked.
over there.
So are you seeing my
I see it.
okay, good. Let me hit refresh. Kevin.
There it is.
Look at that.
Yeah.
Thank you, Kevin. Next up is Martin. Martin's project, the Grassblade xAPI LRS connection. Martin shared a stack that creates an xAPI statement as the user interacts with a video and posts them to an LRS.
So I'm just going to demonstrate what we did as far as using LiveCode to have a video player which sends xAPI statements from the video profile to the learning record provider. So we were using most of the commands from, or most of the verbs in the video profile, and all of the required extensions like context and results, and some of the recommended. So I'll just show you how this went, or how this works. So we have our LRS endpoint and credentials set, and we're using Grassblade. We set actor credentials, and then we open the video player to start the demonstration. So if open video, that maps to initialized verb. Then we start playing, and that maps to the played verb. And we stop, and that match goes to the paused verb, and we can see the data now starting to come in, the progress, the actual time in the video, the played segments. Play again, and pause. We get another result showing we've succeeded. We can seek to a point in the video, and so we can see that the verb seeked is sent. Then we can play, and when it reaches the end, that will invoke the stopped.
From around the world. We hope that you can help us to shape where the technology goes from here. Thank you so much.
The stop statement is sent. Or the completed statement, and then when we close video, then we get the terminated statement. So that basically shows you how it's done, and then we can look at the Grassblade LRS activity stream and just refresh that, and we can see that all of the initialized, played, paused, seeked, completed, and terminated, all those verbs were sent and received by the learning record store.
Next up we have Peter. Peter's demo project, LiveCode Video Project, demonstrates a way for LiveCode Video Player to send a cue. known as a callback to LiveCode when the video file is played past a certain time. Now we'll hand it over to Peter.
When working with video in an educational product, you might want to use the time capabilities of video or audio to trigger events. Here I have a video player that, when playing, triggers the showing of some captions in a field. This technique could also be used for other purposes, such as sending a message to the LRS when the user has played the video to specific timings of the video, or maybe to do some sort of animation based on the current time of the player. Now, a player in LiveCode can play both video and audio files. So what's going on here? You can see this field at the bottom right containing lines with a timing number and some caption text. So when a timing number is reached, the text is placed into the caption field under the video. 15:57 puts Aaron looks up. So how does this happen? Well, we set the video player to contain what are called callbacks, a series of timings and a message to be sent from the player to the program. So at 15:57 in the video, do caption 1, a message is sent to the script of the program. The script receives that message and displays line 1 of the data, in this case, the caption text, into the field. You can refer to the script of this card where I've put comments that explain what's going on and how to use this in your own project. This technique can be used in LiveCode for apps deployed to desktop, Mac and Windows, as well as iOS and Android.
Thank you, Peter. Next up is Andrew's demo, Theory for Keith. This example provided by Andrew Bell demonstrates the setting the browser's contents to a web page contained in a field within LiveCode. This means that content can be loaded externally, generated via scripting, or loaded then modified via scripting.
Hello, my name is Andrew Bell. Today I will be demonstrating proof of concept for the xAPI cohort, dealing with LiveCode and JavaScript communicating to each other. So in this basic proof of concept, we're taking some simple HTML, including a jQuery library, some basic CSS formatting, just sort of visually see our content, and then executing some JavaScript that's embedded in this document. So when I click on this particular button, it's executing a function that is just getting the current date and time. When I click on the get date and time from browser, I'm actually going to then execute a JavaScript function that is embedded in that HTML, and that's going to get that local time from the JavaScript or HTML and put it into LiveCode for manipulation. In addition, this proof of concept demonstrates the ability to determine scroll length on media. So if I embed a local media file into this box, and just doing this by grabbing a file, any media file will do, any visual media file like a PNG, JPEG, PDF, and I'm grabbing that particular binary, and then just creating an iframe and embedding that into this browser widget. So now what that's done is I have embedded a local version of this document into this web page. And so LiveCode knows how large this is. So we have the height information as built in. And so we know based off that height, when we have scrolled to the very bottom of this media file. Once we scroll to the bottom, JavaScript calls a handler that then tells LiveCode. So again, we have this back and forth communication between the two environments. At this point, this is when we would be able to fire off a message for the LMS to know that something has happened. The end user has reached the end of a document. We're assuming that they have completed the task at hand.
Next up, we want to talk about some of the results of the Spring xAPI cohort. xAPI cohort's YouTube channel features 20 videos that were published in the Spring 2021 xAPI cohort. This video will make 21. Also, xAPI cohort in LiveCode GitHub repository features 8 different projects published in the Spring 2021 xAPI cohort. We will be adding links within the README files to each of these to the respective video of the demo as we presented it here today. Thank you for your time. We appreciate you watching.